Today we're talking about lesson 1-9. It's the last lesson of the chapter. You guys are done with chapter 1 after this. It is, yes, we're taking a test next week on Tuesday. Yeah. Not a test every week. You have a quiz or a test nearly every week, but not always. Okay. First example, we are going to check so before we said, is this a solution to the equation? And I would give you like x equals 4, and you plugged in x equals 4, right? Or I would give you c equals 9, and you would plug in c equals 9. Now, I'm going to give you 2 points. I'm going to give you an x value, it's 1 point, an x value and a y value, so a coordinate. And we're going to check if it's a solution. So the question is this, God bless you, is the point 310 a solution to y equals 4x? Okay, so now there's two variables. There's an x and a y. And we're asking, is this point a solution to that equation? Damon, will you put your iPad away for me? The way we check it, and I highly recommend you do this, just to make sure you put things in the right place, okay? This point has an x value and a y value. I would label them. That way when you go to plug them in, you can see x goes here, and y goes here. So basically we're saying if I plug 10 in for y, that should equal 4. What operation's happening between that 4 and x? Multiplication. When they're just next to each other like that, you're multiplying, okay? So 4 times 3. Is 310 a solution?
No.
Why?
Because it doesn't equal 10.
They're not equal. 10 does not equal 12. So when they say, is it a solution? We would say no, because they're not equal. Now here's the thing, guys. I need to see this on your quizzes and tests. I do not want you just to look at that and say, yep, or nope. That doesn't help me see if you're understanding. That's a 50-50 guess, okay? I have to see your work with it. So please, please, please show me what you're doing, okay? All right. How about this one? Still the same equation, but we're going to use the point 520. So y equals 4x. Is the 5 my x value or my y value?
X.
5 is x, 20 is y. So if I plug that in, what is my new equation with numbers instead? 20 equals 4 times 5. Right? So this goes in place of my x, and this goes in place of my y, and then we solve it. So basically we're saying 20 equals 20. Is 510 a solution? Yes. If you get a true equation here, your answer is yes. Okay, so you're plugging in the x and you're plugging in the y. All right, how about this one? If I have the point 4,1 and the equation y equals x plus 7, I want to know, is that a solution? What's my 4? What's my 1?
X equals 4, 1, 0.
X is 4, y is 1. So this is going here.
It's no.
And this is going there, right? So we're saying 1 equals 4 plus 7. So 1 equals 11, which is not true. 1 does not equal 11. So it is not a solution. We would say no, this is not a solution. Okay? One more. Let's say our point is 12,8, and our equation is y equals x minus 4. Which one's my x, which one's my y?
X is 12.
X is the 12, y is the 8, okay? So I'm going to take that 12 and I'm going to put it here, and I'm going to take that 8 and I'm going to put it here, right? So, yeah. So we're saying 8 equals 12 minus 4.
Yes.
8 equals 8 is true, so my answer would be yes. Okay? That is a majority of what you're doing in tonight's homework.
That's it.
I would also say it's the easier thing that you're doing in tonight's homework. The thing that's a little more challenging has a few parts to it, okay? And these are really good problems for the real world, things that you would actually have to come up with in life. So I really want you to pay attention to what it is they're asking for, how they're asking it, and how we can come up with a way to figure it out, okay? Here it is. This is example 2. This is where you're going to use your graph paper a little bit too. Actually, you know what? Before we do this one, sorry, I'm going to rearrange a little bit because I was going to go over graphing at the end, but I feel like it's better to go over it right now. On a coordinate plane, what?
Should we use this now?
Or just draw one of these on your notes for now. We'll use that in a little bit. Can you tell me the quadrants? Do you know which one's which?
Yes.
Where's quadrant 1?
Right there.
Top, bottom, left, or right?
Top.
Top what? Top
Right.
right.
Oh.
Quadrant 1 is here, right? That's quadrant 1. We always use Roman numerals for the quadrants. When we plot a point there, our x value and our y value are both what?
Positive.
Positive. So this is going to be positive, positive. Okay? Where's quadrant 2?
To the left.
2 goes to the left. So 2 is here. And when you plot a point in quadrant 2, one of them's positive, one of them's negative. Which one's negative?
X.
The x is negative. The y is positive. Okay? How about quadrant 3? Which one is that?
By the way.
Dustin, will you put your iPad away, please? Are you taking notes on your iPad?
Yeah, I was on the building.
Oh, that's fine. You got it out halfway through the lesson, so it looked like you were doing other things. All right, so quadrant 3 is here. What are your x and y?
X is
Both negative. You're moving to the left, which is negative, and you're moving down, which is negative. Okay, so that's negative, negative. Looks like a person. And then the last one, need another color here. Let's see. Last quadrant, quadrant 4, is what?
X is positive.
X is positive, y is negative. Okay, so here's what I want you to do. We're going to look, for now, just watch this. If you really feel like you need an example of it, that's fine. You can do it on your graph paper. But I want you to watch me do it so that you're getting it, okay? If I give you the point 3, -2, okay? So we're going to call this point A. 3, -2. Where do I move?
To the right and down.
So you go.
To the right,
And down.
3, down 2. So if it's positive, you're always moving left and right first and up and down second, right? So to the right 3, 1, 2, 3, and then down 2, 1, 2, is going to put point A right there. Okay, this is 3, this is your -2. Where would you be for B? If I said 5, 6.
To the right and up.
To the right 5, right? You always go left and right first. To the right 5, 1, 2, 3, 4, 5. Up 6, 1, 2, 3, 4, 5, 6. That is point B, okay? To the right 5, up 6. Yes, ma'am.
Why is the up and down and then X is right side?
Yep, X is always left and right. Y is always up and down. The way you can kind of help yourself remember it maybe is if you think about an X and a Y, the Y, if you just try to make your leg of your Y a little more vertical, think up and down, right? That leg goes up and down, so the Y goes up and down, okay? All right, how about if I gave you point C is -2, -3. Where are we going to go?
To the left and down.
To the left 2, down 3. So from 0, 0 to the left 2, 1, 2, 3 down would give me point C. Okay, does that make sense? Okay. Then let's get back to the problem. So example 2 is what we're looking at here. Here's what it says, and I'm going to write out all the words for this just so you have something to refer back to. If you're going to write it all with me, that's great. I will slow down and pause so that you can get it all written out, okay? Kim was born, that should say born, sorry. Kim was born 2 years ago. That's not what I meant to say. Rewind. Sorry. Kim was born 2 years before Carrie. Sorry, my bad. Kim was born 2 years before Carrie. They're going to say use an equation, a chart, and a graph to represent that, okay? The reason for all three, I know it feels like overkill, but sometimes some of you are going to get the equation right away, and the chart and the graph you wouldn't get right away, but having an equation will help you get there. Or some of you are going to see it in graph form and have to just convert to one of the other forms. So it's just a kind of like a checks and balances type thing. Make sure that they all work out together, okay? So Kim was born 2 years before Carrie. Come up with an equation, a chart, and a graph to represent that, okay? So let's just start with a chart. Do you guys know the T-chart? Yeah? Looks like this.
Yeah.
Okay. We're talking about two people. We're talking about Kim and we're talking about Carrie, okay? And it says Kim was born 2 years before Carrie was. So technically right here, there's multiple ways you could come up with the equation and multiple ways you could come up with your chart. I'm just going to go with the way that the book does it because I feel like that's the way most people probably would. That doesn't mean it's the only way, okay? You could do it a different way and you could get there. But we're going to say that X is going to be Carrie and Y is going to be Kim. Okay, so in our T-chart, here is Carrie. She's our X. And here is Kim. She's our Y. Okay, so let's think about this. If Carrie is 1 year old, it says Kim was born 2 years before Carrie was. So if Carrie was born in 2010, Kim was born in 2008, right? 2 years before her. Think about what that means for their ages. How old is Kim if Carrie's 1? She's 3, okay? And I think a lot of times the wording throws people off because they go, no, Kim was born before, so she should be the lower number because it says before. But if you're born before, you're actually older, right? So if Carrie's 1, Kim is 3. Okay? What if Carrie's 2? How old is Kim? 4. She's 2 years older, right? If Carrie is 3, how old is Kim? 5. If Carrie is 4, how old is Kim? 6, okay? So there's a relationship there. We have to come up with an equation to show that relationship. So we can say Kim equals Carrie what? How am I getting from here to here, or from here to here, or from here to here? What are we doing to those Carrie numbers to get the Kim numbers? We're adding 2, right? So if we say Carrie plus 2, it should equal Kim, right? So y equals x plus 2 would be your equation for it, okay? Now, if you come up with this first, that's totally fine. Then you can use numbers to plug into the t-chart, okay? And then how we graph it. Here's how we graph it. You're going to take graph paper, and you're going to plot these. Ooh, sorry, I don't have my pen out right now. Here we go. You're going to plot these as points. So you're going to plot the point 1, 3, and you're going to plot the point 2, 4, and you're going to plot the point 3, 5, and the point 4, 6. Okay, so where do I move for 1, 3? To the right 1, and then up 3, right? So to the right 1, up 3. There's a point. Where do I go for 2, 4? To the right 2, up 4. Okay. Then we do 3, 5, and then we do 4, 6. Now here's the deal. You have to think a little bit about this, because this is Carrie, right? Our X, and this is Kim. Is it possible to have a point here?
Yes.
Why? What does that mean? How old is Carrie there?
0.
0, and Kim is 2. So Carrie isn't born yet, but that could exist, right? Kim was born and Carrie wasn't. Is it possible to have a point here?
No.
Why?
Because it's only a point.
Because what?
Oh, yeah, because it's only a point.
Because that means Carrie was born and Kim wasn't.
Because Carrie's negative then, right?
Yeah.
You can't have negative, okay? So we're not going to start here, but you can start from here. Is it possible to have a point here? Can you see which one I just drew? That one?
No. Yes. She can have.
She could be half, right? So this is 1, 2 and a half, and 1, 2, 3, 4 and a half. It's possible for Carrie to be 2 and a half and Kim to be 4 and a half, right? So what I want you to see with this is, if that's the case, you can have points anywhere in here, right? So we should really be drawing a line in to make that graph, because any of those points would work, but don't keep going this other way with it. You don't want to go back here. You just want to start at 0 and work your way up. Okay? Does that make sense? Okay. Let's do another one. Here's the problem. Will runs 6 laps before, pick a name. Who? Before Bob joins him. Then they run together. What is the relationship between, that's my between, by the way, B/T, I mean between when I do that, okay? What's the relationship between Will and Bob's laps? Okay, so look at that problem. Will runs 6 laps around the track, and then Bob joins him and they run together. Okay. Will is going to be one variable. Bob's going to be another. We want to find the relationship between them. First of all, does it make more sense to you to make a chart first, or to try to come up with an equation first, or to try to graph it first? You like the chart first, and then come up with an equation from that? Okay, let's do that then. So here's our chart. And then we need to assign an x and a y, okay? So usually the one that's going to be like the smaller numbers is what we try to put as our x. So in this case, who's running less laps? Bob. So we're going to put Bob as our x. Okay, here's Bob. And then Will is our y. So if Bob runs 0 laps, how many laps has Will run? 6. It says he ran 6 laps before Bob joined him. So if Bob runs 1 lap, how many laps did Will run? Not 12. 7, right? If he ran 1, he ran 7 laps because Bob has run 6, and then he runs 1 more. Sorry, Will has run 6. He runs 1 more with Bob. Okay, so 7. If Bob runs 2, Will runs what? 8. If Bob runs 3, Will runs 9. Okay, what is the relationship between them? What are we doing to the x to get the y? We're adding 6, right? Plus 6, plus 6, plus 6, plus 6. So that is what's going to give us our equation. Can you write an equation for me now? What equals what plus what?
X plus 6 equals y.
Right. X plus 6 equals y, or y equals x plus 6. You can write it either way. Okay, so when they ask you for an equation, that's your equation. When they ask you for a chart, that's your chart. And when they ask you for a graph, you're going to put those points on a graph. Okay, so we are plotting 0, 6. Ooh, I'm going to count by 2s, okay? Otherwise, we're going to run out of space here. So both of those are going to be by 2. So 0, 6 would be 2, 4, 6. 1, 7 would be 2, 4, 6, 7. 2, 8 would be 2, 8, and 3, 9. Okay. Is it possible to have a point back here, this blue? Can you see that blue? Hardly, huh?
Yeah.
Yes.
Is it possible to have a point here? How? So is it possible for Bob to run -1 laps? No. So we're not going to go back that way, right? So we're just going to go this way, but it is possible to run a half a lap or a third of a lap or a quarter of a lap, right? So all the points in between apply. So we're going to draw that line in, and that would be our graph. So this is going to be Bob on this side. This is going to be Will on the y side, and that would be the graph. Does that make sense?
I have a question.
Yeah.
Okay, you said we're gonna do it by 2.
I counted by 2s, right? So I'm counting like this. So this is 2, this is 4, this is 6, this is 8, this is 10, this is 2, 4, 6, 8, and 10. Just because we went up to 9 and my graphs only go up to 6, so we would have fallen off the paper.
Okay.
Yeah, so if you need to change what you're counting by, that's fine. You just have to make sure you consistently count by something different. So if you're going to count by 2s, count by 2s the whole way. If you're going to count by 3s, count by 3s the whole way. Does that make sense? Okay. Any questions on that?
So in the graph, is y the one that goes down and then x is the one?
This is the y-axis. You can't see that very well, sorry. This is the y-axis. This is the x-axis. Okay? questions.